Okay, we're going to start this video by talking about what imaginary numbers are. So imaginary numbers are any numbers that have this fancy looking I in them. So examples could be 4i or 2i squared or anything like this, 3i to the fifth. So any expression that has that little fancy I in it is an imaginary number. So what does that mean? Okay, so I is actually, that was given the value, the square root of -1. So it turns out that when values have negative square roots in them, they actually are valuable, and we use them enough that we actually gave it a special symbol. So any value that has a lowercase, fancy-looking I in it in math means technically that that I is standing in for the square root of -1. So, okay, what do we really do with that? So here are some examples of things that we can actually simplify. So now, if I see something like square root -80, this is really the square root of -1 times 80, because technically any negative number can be written as -1 times itself. Well, we split it up like that because we just said that the square root of -1, this right here, that's the exact definition of I. So if I pull that I to the outside, I'm really just left with square root 80. And I know how to deal with that, so I'm going to do a little tree off to the side. I'm going to break down 80, so I could do 10 and 8, 4 and 2, 2 and 2, and then with the 10 I can go 5 and 2. As I think you guys already know, we talked about this in another video, we're now just going to list out all the primes and pull out pairs since this is a regular square root. So this is really, I'm just going to continue to write that I on the outside. There's 4 2's and 1 5. So if I'm circling in pairs, let me just change my pen color here, I would be pulling out a 2 from this pair and a 2 from this pair, and they're going to come out and join this I. So the final simplified version of this expression is really 4i radical 5. So that's an example of simplifying something that really is going to end up containing an I because it has something negative under a square root. We can do multiple negative square roots at one time and actually perform operations with them. So in this example, I've got 2 negative square roots, so I'm going to go ahead right away and rewrite the whole expression, pulling out that I, which then makes my square roots positive. Oops, forgot my little I here. Okay, so now I'm going to do the same thing I did before. I'm going to do trees for 27 and 48. Okay, so I've got 3 3's. Those are all my primes. So I have 2i square root of 3 times 3 times 3. Okay, do the same thing with 48. Over here, I'll just break it down. 4 and 12 would work. So you should end up with 4 2's and a 3. So again, listing these out. Okay, so again, let me just change my pen color, and we're going to circle in pairs. So from this first radical, I can really only pull out 1 3 because I only have 3 of them. And here, I should be able to again pull out 2 2's. So that means that when I rewrite this, I bring this 3 out and multiply it with the 2, so I get 6i radical 3. And when I pull out 2 sets of 2, I get 4i radical 3. Well, now these are really like terms, so if we remember what it means to add things that are like terms, all we're really going to add is the coefficients, and we're going to keep the rest of it the same. So this is just 10i radical 3. So that's another example of simplifying negative square roots and then actually combining them and getting one simple expression. So that's one thing that we do that deals with I. So the next thing that we have to talk about with I is what happens when we start raising it to different powers. So if you remember from class, what we ended up figuring out, I won't go through the whole thing here because it'll take a while, is I to the 0, like anything to the 0, is 1. I to the first power is just I, because anything to the 1 power is itself. We saw when we multiplied 2 i's together, I squared actually gives us -1. So I squared actually doesn't end up being an imaginary number once you simplify it. And I cubed is -I. So again, we went through this in class. We figured out how all of these things work out. So it becomes this little circular thing that now if I just give you any random power of I, let's say I give you I to the 35. If I go around and around this little circular sort of clock is what we sometimes call it, I know that I can figure out where I to the 35th would land. So 0, 1, 2, 3, all of your multiples of 4 are going to land back on that 0 because you're going to get around. This is going to be I to the 4th right here at the top. Then we're going to go around again, 8. So you can kind of keep going, and I know that since 32 is a multiple of 4, 32 is going to end me right at the top. So then I go 33, 34, and 35 would land right here. So that means I to the 35 must be negative I. So this is like the old school way to figure out the values of the powers of I. Now, luckily, we do have technology on our side here. So I'm going to show you how you can do this in your calculator. So I took a little screenshot, hopefully you can see that, of how you get to this function on your graphing calculator. So if you press the math button, you go over to the num menu, you should see exactly what you're seeing on this page is this I part thing. So if you go ahead and actually put, just like we did, do I part of I to the 35, the one that we just did by hand, and that should give you what we just came up with, which was negative I. And that's what I get on my end, so hopefully you got that too. So we use I part anytime we're dealing with large powers of I. So here's some more examples of big expressions that have i's to powers in them. My suggestion to you always is, so that you don't end up making any calculator mistakes, is that you try to simplify your expressions first. So what I mean by that is, if we look at this first example, I know how to divide this and I know how to deal with my laws of exponents. 6 divided by 3 is 2, and when I divide, I subtract exponents. So this is really 2i to the 8th. Now I'm going to go back to that I part menu and I'm going to type in 2i to the 8th. You can put the coefficient in there as well. So again, press math, go over to the num menu, just like, and you should see what I see here on our screen, and you're typing 2i to the 8th. And you should get positive 2. Okay, so something like this next example, you've got multiple things that have i's in them. There's no rule for adding expressions like this. We can't do anything with the exponents, so you're really just going to have to calculate each one individually. So my suggestion would be put each of these expressions into I part individually. So I'm going to start by typing in 2i to the 12th, which should give you positive 2. Now I'm going to type in I to the 17th. That should give you I. And then finally, you're going to type in negative 3i to the 10th. I recommend putting the sign in there so that you don't get confused later about where that negative should go. So you're going to actually type negative 3i to the 10th. So again, you can put that whole thing in there. And you should get positive 3. That's what I got on my end. So once you've done this, you've figured out what each individual power comes out to be. You can combine like terms. 2 plus 3 would give me 5. And the I doesn't have anybody to go with, so that just sticks on as part of our answer. So my final answer is 5 plus I. Okay, here's another example. In this situation, what we would always do with this type of expression is we would distribute our power. So again, I don't recommend trying to put that whole thing in I part. Sometimes there can be a little glitch. Your calculator doesn't always understand what you're asking it to do. So if you can just put in one single expression, that's always better. So you're cubing 4. That should give you 64. And the rule when you're dealing with powers, if I have one power to another one, I multiply them. So this is I to the 18th. So now, again, I'm going to go to my I part menu, and I'm going to type in 64i to the 18th. And you should get negative 64. So you're never ever leaving answers like some of these ones we got initially. You would never leave something like this, or any of these guys by themselves, or this. You can never leave expressions that really have any powers of I, because as we just saw, every single power starting at 2 can simplify into something even simpler. So those are some examples of what we do when we do encounter I to powers, using that little helpful function on our calculator. Okay. Then we start talking about what are called complex numbers. So complex numbers is sort of like a larger heading that includes both imaginary and real numbers. So an example of a complex number is anything in this format, a plus bi. A being the real number. So this could be anything, 10, negative 5, a million, whatever. And then the bi part, this is the imaginary part. So remember we said anything with an I on it is an imaginary number. So complex numbers really brings together real numbers and imaginary numbers. So some basic stuff we can do with complex numbers. We can multiply, divide, add, subtract. So here are just a couple of examples. What's kind of nice is on your calculator, you should be, because we did this in class, if you press the mode button, just make sure you're in A plus BI mode. That's what your calculator should be highlighting. And as long as you are, you're allowed to type expressions such as these right in your calculator. So on my screen, I'm putting parentheses 4 plus 5i, closing the parentheses and squaring the whole expression. And you should get negative 9 plus 40i. Now, if you wanted to, you could write out 4 plus 5i twice and do all of this by hand. You're welcome to do that, but I think there's a big chance that you're going to end up making a mistake. So you could double distribute this and put each term individually into your calculator to simplify, but again, I think it's just going to take you a lot longer. Same idea with this second example. I can type that exactly how it looks on the screen into my calculator screen. I don't need IPART for this because it doesn't have any powers. So I'm typing 1 minus I in parentheses and then subtracting, again in parentheses, 4 plus 2i. And I get negative 3 minus 3i. Again, you probably could do this by hand. If you distributed your negative and combined like terms, you can see that 1 minus 4 gives that negative 3. And negative I minus 2i is where the negative 3i comes from. So you're always welcome to do any of this stuff by hand, but again, the calculator just kind of helps us take some shortcuts so that we don't waste time or make any silly mistakes. And that's pretty much everything you need to know right now about imaginary and complex numbers.